Hello everyone, and this will be our last video to try to make up for the snow day. I have a new program here for you, and let's walk through it. This is going to show the three different kinds of loop controls. And so we have Sophie and Jack running against each other in various contests. And so I have my scanner, which I bound to my keyboard again, and I have two int variables, one for Sophie votes, one for Jack votes. They are initialized to 0, no cheating there. And so this first loop is going to be counter controlled. And it's going to be counter control based on the precinct. This particular voting district has 3 precincts, numbered 1, 2, and 3, and I hope I spelled precinct correctly. And so you can see that precinct starts out with 0, but in my print line, I add 1 to it. So when precinct is 0, this will print 1. When precinct is 2, this will print 2, and so forth. The counter control loop initializes my counter, and I test when the counter passes some sort of threshold. Now, counters can go up, they can go down. They don't have to always use 1 as their count value. They may use 2 or 500 or something like that. Usually the count value is fixed and consistent though. A very, very important thing I said earlier in the introduction, the something in the loop body must, or something in the condition, in this case it's the loop body, which is the normal place for it, something in the loop body has got to do something to eventually flip this counter to false. Otherwise, we'll never finish the loop. So let's go on and run this very briefly. Run as Java application. So, how many votes does Sophie get for precinct 1? Let's say she gets 6 and Jack gets 5. For Sophie, for precinct 2, Sophie gets 5 and Jack gets 6. And for precinct 3, they both get 2. And we come down here to a set of nested if statements. If Sophie gets more votes, we print Sophie 1. Else, the else clause for this if statement, the else clause starts right here, and it includes this if statement. Well, this if statement has an else clause, so the else clause for this first if statement on line 23 is the if statement that starts on line 24 and continues through line 25. This is a common way, nested ifs, common way that we do case processing with if statements, and you'll notice that if it's a tie, this political jurisdiction just flips a coin. So that's it for a counter controlled loop, and I recommend that you look at these patterns. Get the counter control pattern, the sentinel control pattern, and the accumulator control pattern in your head, so that when you come up to a problem and you say, well, this needs a counter controlled loop or something, you can just stamp this pattern out without thinking too much about it. So now let's move down to the sentinel control loop. A sentinel is a flag, and in this particular case I'm going to ask for Sophie's votes first, and when the user wants to quit, they can just enter -1. And it turns out that I'm still running this thing down here. And let me see if I can move it up a little bit and move this down a little bit. And so if I enter -1 here, immediately, this is called the priming read. and I'm priming my loop just like I would prime a water pump. And so if I enter -1 here for the new Sophie votes, this would immediately be false because I'm testing for not equal to -1, and I would skip the loop body completely. That's a characteristic of pre-test loops. There's also a post-test loop in Java. We won't be covering them in this course. There's nothing wrong with them, but if you want to learn about post-test loops, they're in the book. So I set the priming read to get the number of votes Sophie got. As long as it's not -1, I add that to Sophie's votes. I get Jack's votes, and this is the update read. This is a characteristic pattern of a Sentinel controlled loop. We have the priming read to start things off, and then we have the update. So let's say that Sophie got 4 votes and Jack got 3 votes, and those were all the votes that were cast, and Sophie wins. Did I not get the if statement there? Well, exercise to the reader, put in the if statement here to print out the winner from the Sentinel controlled loop. Now we come down to the accumulator controlled loop, and accumulators are sort of like counter controlled loops, but they don't necessarily go up or down by a consistent amount. And so my test for this particular loop is, well, as soon as somebody gets 100 votes, they must win. So I keep going as long as Sophie has less than 100 and Jack has less than 100. Whenever one of these candidates gets 100 or more votes, I'm going to stop the voting. So Sophie gets 55 votes, and Jack gets 66, and Sophie gets 33, and Jack gets 44. And so Jack's 66 plus 44 is more than 100, and it turned out that Jack actually won. Again, exactly the same nesting going on down here. So that's going to do it for this set of videos. One thing you could do as a little bit of work, in addition to putting in those if statements to determine who won in this Sentinel controlled loop, is to put in some if statements inside the loops that we have here, and print out who's ahead. You know, Sophie is ahead, Jack is ahead, or they're currently tied, something like that. Some very other brief notes. We will not be using, you do not ever, or well, you very, very seldom, let me put it that way, use these relational operations to compare objects. This is a big problem for you C++ guys. You're used to using relational operators to compare objects. We don't do that in Java. We use the dot equals method. We'll talk more about that in class. There are a couple of other statements. There's a switch statement, which we're not going to cover. There's nothing wrong with the switch statement. It's kind of like the post-test looping. If you want to learn about the switch statement and use it, be my guest, go for it. If you use the switch statement, inside a switch statement, you will have to use a statement called break. I'm not going to be covering that, but break statements should only be used in switch statements, and there is a statement called continue. Continue should not be used under any circumstances in my classes, period. I was an old Fortran programmer. I know a go-to statement when I see one, and break and continue are just go-to statements with implicit destinations. We will not be doing that in polite company. If you're going to use a switch statement, though, you have to use a break inside the switch statement, so I will allow that. And that is pretty much what I wanted to cover for these videos. Just to recap a little bit, We've done the control structures, if and while loops, very, very briefly. And we've done the three ways of controlling loops very, very briefly, counter, sentinel, and accumulator. We spent most of our time looking at conditions and using relations to generate Boolean values to specify whether or not the relation held. And then we combined those relational results, those Boolean values, with logical operators to come up with more complicated results, such as did the user enter my birthday, or did the user enter a day in spring. And so hopefully this helps from missing day for snow day, and I'll look forward to seeing you in class soon.